All right, so we're looking at the pivot lab, and in particular, this is a density 2 lab, but the density of the bubbles. And what we're going to do is we're going to look at density of gases. So you're going to start out here and look at the first video. In the first video, they're just explaining to you what they're going to be doing. And so they're going to be taking and hooking up gases so that the gas goes into this empty container. The first thing they're going to do is turn on the vacuum pump, empty the container, and they're going to put the gas in, and then we're going to weigh the gas and see what the gas weighs. Now we're doing this because if we come down here, we need to fill out this chart. And with doing this chart, first of all, because this container that we're going to put stuff in, and I'm just starting with air for no good reason, because we're going to do all of these, you're going to hit the play button. And when you hit the play button, the first thing it does is the air out. All right, and then it's going to close things off. So it's going to pull the vacuum away and close this container off. So now it's empty. So now we're going to we've got an empty container, and we're just going to put air in. And he just opened it up and let air go in. Now, when it finished doing this, we're going to take a look at the mass. And when we take a look at the mass here, what we're looking at is this value right here, 1.18, and this is how much 1 liter of air weighs in terms of our, in terms of grams, and you're going to take and you're just going to put that data right in here for the density. Because this is a 1 liter container, you can simply type in that 1.18. So let's change it and let's do this stuff. Now, you want to know what kind of gas that is. You can take and look that up. But here we're going to just take and put it in. And again, we're going to empty the 1 liter, i.e. there's nothing there. Now, when you look at this, you will see that both ends are closed. So that container is completely empty. Now they're going to put the balloon up to the right-hand side. Setting the mass, putting the balloon up to the right side, and now they're opening. Now they opened the other side as well, so that the pressure equalized at 1 atmosphere. And then they took and they closed it off. And when we're finished closing it off here, we go to this very end value of 4.76. That is the mass of this gas. And you're just going to come down here to your chart, and you're just going to type in your 4.76. And these are going to give you your relative densities. And once you've got all of these in, they're just going to ask you to put them from the least dense to the most dense. So the smallest value of grams to the largest value. Then they're going to take here and you're going to do some math here. And to do some math, we're going to do butane. So let's just quickly do butane and load this one up. Press play. So again, we're going to evacuate it, take all of the air out, close everything off, take the balloon that contains the butane over on the right-hand side, open it up, and then the butane is going to flow through. We're going to close everything off, and then we're going to look at the mass of this at the very end, and we look at the mass at the very end here. We're going to get this 2.39, and that is going to be the mass or the density of our butane, and that's 2.39 grams per liter. That's the value that I got from the experiment. They're asking here, what is the volume in liters of 91 grams? Well, if you know that you have your of course, I lost my number. You have your 2.39 grams per liter, you can figure out how many liters you would have in 2.91 grams. Then we're going to do some buoyancy, which means float or sink. If it's denser here than our air, it's going to sink. If it is less dense than air, it should float. So these are the gases that we have. And then we're going to answer some questions on these. You're going to predict. You're going to take a look at these 5 gases right here, and we're going to predict whether or not that they would sink or float. Once you do that, we're just going to try them out. So here, if we compare, and what we're looking at is the gas in the tank and the gas in the bubble, and we are comparing them. So if we do this, and we're going to start out here with bubble gas of argon and the gas in the tank being nitrogen, and we know what our densities are in those ones, so we should be able to predict it. And they're going to take, and what they're going to do is this fish tank has nitrogen in it. And we're taking and we're putting bubbles of argon here into this. So they're filling this up with nitrogen. They're putting it at the bottom so it displaces any air that's in there. So it's going to have a nice full tank of nitrogen. And then on the other side, we're going to put some argon. Now we're putting that into soap so that we get bubbles. And then we're going to take, and we're just going to let go. And it's going to be, will it float or will it sink? If it is more dense, it should sink. If it's less dense, it should float. And then you are going to answer the questions from there.